In this part, we'll try to implement benchmarks. So it would be here basically comparing ourselves to the dictionaries that are in base Julia, so mostly Dict for now, I think. And we'll also try to add some documentation, so that's the second step. Add the examples to our continuous integration, because what happens often is, so let's check the package. So what happens often is we test everything, so we test the behavior in tests, but then we have examples that are not tested. And after some time, if you work on the package, you can forget to run your examples. And if you do that, you might have examples that are not validated, and you forget them, and then they're deprecated, and you don't remember what you wanted to do in them. So if we take a look at examples, what we would like to do here is just run the file, and this should not error. That's it. That's the only thing. And so if this errors, this should make our this should make Travis error itself. Okay. So first thing, benchmarks, examples in CI, and then maybe documentation. All right, let's do it. So now that we have a whole GitHub page set up, and so the whole project properly set up, we will try to work in a more standard open source flow, meaning we will use branches to do our work. So let's try to start with examples. Examples CI. Example CI. Okay. So here this should be rather quick. It's mostly adding a script there to say we want to add a step after running everything that validates the example. So since Travis is fairly hard to remember, Travis syntax is a bit hard to remember sometimes. So what we'll do is just copy something from another package, which is distributions, on which I sometimes work a bit. And I know, so we have pair, for example, and other things that are in Travis here. So after success, after success is the same thing as we have. Let me zoom in a bit. Branches, maybe we should add that, but no, for now we just add this. We'll just basically copy paste widely. That was the after success. No, that was jobs. Do we have a no? Yeah, we have after success, and then maybe we need also branches for this. Yeah. So this thing here is saying only run the special things there, only for master and the releases. So v dot something, which is a release syntax. Okay. So jobs allow failure on nightly, fast finish true, include. So documentation, we're not gonna do it yet. So this means we have to comment this out. Stage documentation. Or we'll just add a stage examples. This will be Julia 1.0. OS is going to be Linux, which is usually faster to run things than OS X. And scripts 1.2. So Julia. So project would still be this one, or just Julia project. I guess this should work. And examples / examples.jl. Okay. And yeah, this should do it. So this will now error if the examples are not correct. So for now, we're just gonna comment out all the rest of this file, and we'll re-add it when we add some documentations or benchmark or stuff like this. Okay. Oh, this is stage, not okay. Alright, so that was the easy step. So add a stage which is called examples in CI. Push origin example CI. Oops. So we'll create the pull request for this, and this will trigger Travis. So it means Travis will then should run our examples, and they should work. Okay, so #dict examples in CI, create pull request. Okay. And Travis does take a bit of time, so we're not gonna wait on it. We'll just okay. Yeah, I think the rest of it is after. Wait. Okay. Why is this open? This should be open on Travis, not GitHub. I think this is, yes, this. Okay. So we'll see everything happening in here. Okay. Just to check, yes, the only file changes this one, and we need a return line also. For now, just keeping things clean. Return line, the end of file. Alright. So that was it for a moment. For examples, we'll wait for continuous integrations for Travis to finish everything here. In the meantime, let's switch to benchmarks. Check out master. Oh, go back to master and branch benchmarks. So benchmark are basically checking how fast things are compared to something else. So here we have the comfort of having a base implementation of dictionaries in Julia, and we'll compare our implementation to it for different operations, different sizes, and so on. So for this, due to the compilation process of Julia, a function is compiled in its specialized form when it's called the first time you run it. So here, if let's define a function add, which takes x and y, and this return x plus y. No surprise here. Okay. Now let's time how much time and memory does adding two integers take. Okay, so that's some allocations, some kilos of allocations, and that time. Okay, now let's run it again. And this is now much smaller, which does make sense. We're just adding integers. And also much faster, which makes sense. We're again adding just integers. So now if we do it again, this should roughly stay the same, except for some minor noise. While the first run is always very expensive, because the first run is not only running our function, it's compiling it in its specialized form. So if we now use add, but we have a new type, this is going to specialize the function for floats, for two floats. So the plus which is used here is also going to be the specialized float plus. So if we run this first, we're going to have again a long compilation time and more allocations, and then if we run it again, this becomes very low, and yeah, roughly the same time as for integers and a bit more allocation. Okay. But yeah, so the main point is you cannot just time things. What you could do is run all your functions the first time with their argument, and then run them again and measure the time. So time is in base Julia. You can measure the time gone for a specific operation. Instead, what we're gonna do is use refresh. Okay. Okay, so we have. Is it running our examples? I'm not sure. Yeah, maybe we should add some verification to check that. Okay, so I guess we're finished for now. So this is the big thing on benchmark. We're gonna see that later. For now, we're gonna check back to examples. Maybe in Travis. Yes, so we'll add info. I think we can use single quotes here. So this will at info running examples. Yeah, or we don't need to escape if we're in single quotes. Okay. So this will just print this line or info this line for us to have a more informative log here to say at this point we're running the examples. So log at example 4. Okay. So this will run again. So in the meantime, so the thing we're going to use is called benchmark tools. So you have different packages for benchmarking functions. So this will basically ignore the first run, which is measuring the compilation time. And then on the multiple runs that follow, you can choose a number of samples and a number of runs, which it will average to smooth out any external noise and so on. So the basic way to use it is, it's an external package. You just add it like this, and then at benchmark will give you some info on what time does it take to run this function here with this setup here. So setup is not counted in, it's just run once. Okay, so what we'll do is just for a given dictionary, which can be either ours or the base dictionary, run some operations and give us the time it takes. So we're not going to use any of the fancy things in benchmark tools, just going to use the very basic stuff. Okay. We are now, no, we're still, let's get back to benchmarks. So we, for now, if we look at what we have just things that belong to our project. So we have the example that are run just with our project, the source, which is our the source of our project, and the test. What we'll do now is create some sub-projects inside, which is what people do for documentations, benchmark, anything when you need something that, you need an additional dependency that your source code does not depend on. So you don't want to add it to your project directly. So we'll create a benchmark folder. Oh no, sorry. We'll create it with generate. That would be easier. Benchmarks. And from here we'll just use generate benchmarks. So this will generate a new folder, benchmark, with a project and some sources. In that case, we don't need the sources for benchmark. We just need the project. And so we are now in the benchmark project. Let's check. So we now have a name benchmark, UID, authors, and so this benchmark project will depend on two things. First thing will be our package. So we'll add, so you need the absolute path here. Documents project projects #dict. So you need the full path to your project, since it's not anywhere else. And also it's using the last version, which is the one you have locally. So we need this, and we also need benchmark tools, which is how we're going to measure things. Okay, so if we now look at the file, we have two dependencies added. Maybe we should, so we're not going to version #Dict because we're always using the local version, but we might want to version benchmark tools project to keep compat, yes. So compat is Julia 1, and benchmark tools, the one we're using, we'll just use the latest, in that case 043. So wait, what? That's not the, oh no, it's benchmark project, that's what we want. Okay, then compat Julia equal 1, and then benchmark tools equals, did we say 0.4? Yes, so 0.4, we don't have to specify the minor version here. Okay, I think we have everything here. Let's get back to this. Yes, okay, perfect. So what we'll do is just we'll add a benchmark.jl, and here we'll just benchmark everything. So using #Dict, #Dict, and using benchmark tools, benchmarks. No, yeah, benchmark. Okay, so so we'll create a bunch of benchmarking functions, which could be, so it's going to take a D, which is going to be any of the dictionaries we have, either #Dict or the Base.Dict. So this function will be atomic insert, yes. No, maybe not atomic. Atomic is maybe a too specific term. Unit entry insert. So this will oh no, yeah, we can just use the fact that it's going to be an abstract dict of K and V, where K, B. So what we can do here is random entry insert, and we are also going to use the random module from the standard library. Okay, so random entry insert is going to assume K and V are two random things, and going to take optionally RNG, which is random abstract RNG. It's going to take that with the default, which is random.global RNG. So that's going to be a default by default, but if we want to make things reproducible, we want that to be we want sometimes to pass it. Okay, and then this will also take a number of, yeah, this should probably be last, number of entries, and this. Okay, so this will for in 1 to number entries. So for 1 to number entries, we are gonna produce a random key K, yes, like this. So this is producing a random item of type K with the RNG, this, yeah, maybe not. I was thinking that because of this, what we're gonna benchmark here is more the it looks more like we're gonna benchmark the random generation process. So maybe we should just have a key iterator. Key iter value iter. So this, we're gonna pull values out of this and this, because you don't want to. So random generation is, let's say, relatively expensive compared to the other things we have, like creating a hash or inserting into a structure, and we have a risk of benchmarking the random generation process instead of that. So it means here we will just do it deterministically for now. It also makes the function simpler. So for k value in zip of key iter value iter, so the dictionary at key equals value. Okay. So another thing we can do is so the function, so it's not random anymore. Iterated run entry. So yeah, this sounds more descriptive. So the second thing we can do is use the get function with the default safe get. So we're not testing the behavior here, we're just checking how fast this is gonna be. Save get functions. This is an abstract dict. Key iter. So this is assuming here that D has been populated already. Or does it? Yes, okay. We're just gonna do things simply. KA. Maybe we can simplify it after. But so this is gonna call the Base.Get function with a default. And default has to be a K. Okay. So for key in key iter, value equals get of a dictionary at the key with default. And now maybe we should test is key. We should do something with value to avoid it being erased at the compilation. I'm not sure how aggressive a compiler would be with this. Default. Yeah, maybe we could add default counter. Equals 0. So if v equal default, default counter plus 1. Oh yeah, we can put this on another line. If okay, so this is using v for something, so it's not gonna erase it. So this means this operation is gonna be performed. Okay, and maybe return default counter. Okay, yeah, this is returning nothing already, but we can do it explicitly. This is just a habit. Okay, so save get, and another benchmark we can do is maybe the normal get function. And save get index d. Let's just copy this. No, without that. Key either, or we don't need K and V here. So this is about to do the same thing as before. Key either, if has key, so dictionary keys be equal d of key, I'm not sure what we're gonna do here to avoid eliminating things like compilation. Found plus equal 1. Okay. Return found. Okay. So we define 3 basic functions to benchmark. So let's say insert basic benchmark. So this is going to create, so our key either is going to be a random value. So we're going to create ints rng tract rng equal, we're going to give a default random dot global rng keyer, so we're gonna number of items let's say 3000. Let's put exactly, but no, yeah, something like this. So keyer is going to be random values, random integer values. Can we give a number here? I think so. Number items. We're gonna check it later. Import. So first thing is add random. Import random. Oh no, in normal mode. RNG equals random global generator for now. Number items equals type of key either. I think this worked properly. Yes. Okay. Alright, so this is creating random integers. Can we create random strings? No. Value either equals string of key either. And then we're gonna benchmark, iterate. So this one first. So for the in, so we're gonna use a type unstable loop here, but it's fine. For D in so dict, yeah, so it's gonna be of int string. So we're gonna create an empty dictionary here and empty hash dict. So for both of these, benchmark, I think we have to escape here. This is in the manual. Or we'll see if we have an error or not. Benchmark that benchmark the keyer valuator. Okay. Yes, so we said I think we need to escape here because this is generated at compile time, because that benchmark is a macro. Info benchmarking marking, yes, type of D. So we benchmark with this, then we can benchmark the safe get, so this thing with just keyer. So this will be info marking on existing keys, save get function, so we're gonna benchmark it this and unsafe get, so these two will be fine. And then let's create new keys, so new random keys, so the same number, so some of them will overlap and some not, and then benchmarking on new keys. Okay, so we'll see first what does it do. So run, I think we can just run. Did we save benchmark here? Benchmarks.jl, yes. Where are we now? Yeah, we're in benchmark. Wait, are we in benchmarks? Oh no, we created the benchmarks.jl not in the benchmark folder. Okay, now we can run benchmarks. No method matching run. Okay, nope. Never mind. Oops. No. So not run include. Oh, and we did not run the function, obviously. Nope. Benchmarks, benchmark. Basic. Yeah. Maybe we should. Oh, did we re-import? Do we have no import random because we deleted it? And then let's say random.seed. So this is setting the random seed to have reproducible benchmarks. We don't have to do it, but I think it's a good idea here, at least for the beginning. And so since we're using the global RNG, we don't need to specify it. And yeah, let's run first with 1,000 and then 5,000. Okay, so this here will not, the trick is here we're not going to resize the dictionary, while here we're gonna resize the hashtag. So I expect this to be fairly reasonable in performance, and then here we're gonna be bad compared to the Base.Dict. All right, let's run this. So this might take a while. In the meantime, maybe we can check how are our examples doing. So if I refresh this here, do I have some info about? No, I don't. Oh, I think this is only on master. Should we allow it everywhere? Yeah, I think we should allow it everywhere. Oh, in the meantime, alright, let's focus on the benchmarks for now. No method matching. This and this. Okay. Alright, no, yes, we made a tiny mistake here on the save get. So default key, and we called it with the values, while the value should be just unsafe get index. Save. So this should be, yes. So the save should have a default, and the same thing. Save get here. Yes. All right, like this. This should work. Yeah, let's turn on the benchmarks for now. They don't seem to be taking too long, so we're just gonna focus here, and then we'll go back to the example business. Save get functions. I'm still doing it wrong somehow. So where did this happen? At benchmarks 52. Oops, no, sorry. Here, yeah, great. This is on this benchmark 52, benchmark 36, benchmark. So I don't think it's 36, but this might be the macro expansion which tricks us. Basically 42. Yes, 42 is here. Save get function. This is supposed to take a default of type value, obviously. Yes. So that was, yep, sorry about that. And same thing. Yeah. So that should be. So we also forgot to update new key benchmark. Okay. Let's run this. So this is recompiling the functions every time. Since this is not in the source folder, we're just including the script, which is basically running everything. So re-updating the functions and so on. Did we? Is it not supposed to print the benchmark? Yeah, I think it is, but benchmark might be returning the string. Do we have? Yes. So benchmark is returning a benchmark, but maybe we should add info it. Yeah, I think so. Okay, so yes, I think we should. So every time we have a benchmark, we should add info it, or maybe println. Yeah, println, because this has to be evaluated after. So this is returning a benchmark type, benchmark result type or trial type. Yeah, that's gonna be better. Okay. So the big thing is, yeah, we should also indicate how many items we're using. Items. Okay. So I think now this should print things we want. Trial, this is fairly minimalist. We might want a bit more. I think we should use show instead of println. Like this. Yes. To have a bit more information when we run our benchmarks. Yeah, not great either. How do we show more info from the benchmarks? So this is returning a benchmark trial. So let's try to see how this works. Benchmark tools. So this is what we want to print. We want this report every time. So if we do this, we don't get anything because this is just returning the expression. So trial equals this. And then trial, so it display trial. What if we add show trial? Yes, that's I think what we want. But if we do that, yes, we just get the super tiny thing. We don't want just the minimum, we want this full report, I think. So in that case, we have to add show things. I hope it's not gonna mess the order, because yeah, macros are modifying how the code, what code is actually run. So I hope this is not gonna break everything. Oh yeah, this is ugly. Let's kill this and restart. Oh, that's even worse. Yeah, that's not great. Okay, let's check the documentation maybe. Linux tips. We should maybe not try to use OS specific things. No, yeah. Let's not dive into that. The manual, interpolating, set up and tear down, handling benchmark results. So no, dump is a bit too much. Okay. Median. So we want just something to easily pretty print things. So if we println a benchmark, let's just try to restart a toy project on the side using benchmark tools. Yes. So how do we pre-print this object? Display trial. This might be this. Yes, okay, we want to display it. I hope this is working properly. Display topmost applicable display. Okay. What about show? Show is supposed to do it too. No, show is not doing it at all. Okay, so display should do it. Okay, like this. Yeah, that's better. So that's all with all these. Let's unzoom a bit because yeah, this is gonna get long. Oh, yeah, not that much. All these are for Dict. And maybe we should put them side by side. That would be cool. Or maybe store the results and then print them side by side. So that's around 7, 8 microsecond for existing keys. Oh yeah, wait, we're bad. Okay, we're not that good. That's not much of a surprise, but so this will be 1,000 items. So we are roughly twice worse. Benchmark hashtag. So this is here for insertion. And how was insertion for the Dict? 10, 10, 11, and we are at 30, 34, 40. Okay, interesting. Then existing, we're at 19, 20. Well, it was at 10. And 30, that's for the next one. New keys. Okay, new keys, I don't think we're that bad. Yes, we are. So 7 versus 20, okay. And then this is where we're gonna be bad. Okay, the good news is the Dict themselves. Oh no, it's not that much worse. So the Dict is at 62 microseconds for inserting, and we should be worse than that. Dict. Oh, yeah, okay, we're bad. It's a 10-fold, no, 5-fold worsening, which is okay because I assume there will be some fairly advanced tricks in Base Julia for this. So we should check maybe how performant this is. Well, at least now we know how bad we are and on which operations. So the thing we could do is collect the benchmarks one by one, then zip them together. So we have a bunch of benchmarks, and for each one we have the tuple with the type of Dict and how good and yeah, the type of Dict and the type of and the results, sorry, for each one of the types. Okay, and for each of the operation we have this. Okay, so at least now we have benchmarks working. They're showing how bad we are, but that's a fairly good point to have. So now you have this, and when you're working on performance specifically, you run the benchmarks and see how good or bad am I. Okay, so I think we're good now for the benchmarks. They just make us cry a bit, but that's okay. And we're not gonna add this to CI yet, that's fine. We're not gonna add these to CI for the simple reason that benchmarks is very expensive and you should not stress your CI too much, otherwise you're always waiting on Travis to finish. it's often the case. You're often waiting on Travis to finish, but don't push it too much, otherwise this is just sad. Okay, so we added benchmark, yes. Maybe not the manifest. Git ignore. We should ignore all manifest maybe. Does this work like this? Git ignore. This should not be adding the manifest. Okay, yeah. Added benchmark project. So this will be on a benchmark branch. And if you want to see some more advanced benchmarking examples, yeah, you can check the ones in benchmark itself, which is fairly interesting to have. Yes. So they have a benchmark folder in benchmark, in which I'm not sure what exactly they benchmark, but they have some more advanced features that they use. Okay. Yep, I think that's it for benchmark, and then the examples are still not running. So for now, we'll go back to the example branch. Micro. Okay. So for now, maybe we should, yeah, either we remove it, or yeah, we'll remove it for now. We're gonna re-add this maybe afterwards. Ah, no, this bothers me a bit too. Yeah, maybe we should just add script after success. Yeah, after success we could add this. Julia E. Yeah, like that. Oh, did we remove? Yes, oops. Didn't mean to remove, because, nope. Where is my, I'm going too far in the indeed. Okay, get diff. Yeah, I want that back. Alright, so this is like this, okay. So we, after success, we now have two jobs, which is pushing the coverage and then running the examples. Maybe running the examples first. I'm not sure this will error if we fail on the example. That would be sad. And then stage here, we don't have example stage anymore. I'm not sure this is valid syntax. We'll leave this here for now. Alright. Add examples in after success. Alright. So this is pushing. We can go back to our great #dict. So we now have our example pull request, which is updating, and we'll add our benchmarks pull request at benchmark project. Okay, so given the time we took on that, maybe we should stop here, probably. So benchmark is not doing anything on Travis, so it should not fail. We'll just wait for it. And examples, yes. Conversation. try this. Okay. So this is now running here. And yeah, maybe we should stop there. We could do the documentation in a future video. For now, so we're gonna wait for the examples to run. So they're supposed at some point in the log to print something, to print running examples, namely. Okay, info running examples. So this is a success. Perfect. We're now running the examples after the test pass. So if the test fail, it's no use. Otherwise, this is just a minor additional check to run the examples and see are these okay? Did we not break the examples? So like this, you can consider the examples part of your CI and part of your documentation. I mean, tests are fairly good to test all the nifty details of the underlying data structure. Examples are just showing how do you use a Base.Dict in real life, and so there's not supposed to be any trick in the implementation. It's how users will do it, and with this we're checking that how users will do it, or at least how we show users should do it, is running fine. So that's great. This means that's here, and yeah, we could wait for it to finish correctly. In that case, I'll consider it okay and merge it. So you can delete the branch afterwards. And since benchmarks is not being really tested, we can also merge it directly. So again, since example, and benchmark is almost finished. So again, the examples are just using things from the project itself, from Base.Dict, so we don't need to add anything. But otherwise, we could have an additional project, which would be the examples project, with its own dependencies, its own structure, and so on. All right. So that would be it.